Hello, everyone. I hope that the lunch has been slowly digested in your belly, and I will make a nice digestif for that, so the digestion goes perfectly fine. The organizers of this conference were very kind to give speaker training to all the speakers. I did not actually attend, so you're not going to benefit from it. But I looked through the slides a little bit, and one of the things that was on the slides said, you need to tell your audience who you are so that they know why the hell do they care about what you're saying. Maybe the stuff about hell was not on the slides, but the message was approximately like that. I joined the Dart team 11 years ago and has been working on it since. Originally, like I know, 11 years ago, I would give some talk. I would say that I'm a software engineer on the Dart team, and then move on with my talk, something about compilers or virtual machines or something like that. But things slowly changed over the years, and I became a team lead and manager for a significant portion of the Dart team. So I stopped saying that I'm a software engineer because I am now rarely writing any software, and I'm mostly writing documents and telling people where to go and where to find the hidden treasure. But as I was preparing for this talk and making slides, I thought, well, this is all just labels. They talk about my, I don't know, day-to-day job. But in reality, I'm neither a software engineer nor a team lead. I'm a dreamer on the Dart team, and I dream about things. So this talk is about things I dream on the Dart team. Yeah. I have been suggested, that it has been suggested to me that I should put a small disclaimer here that nobody has actually seen on the Dart team, on the Dart DevRel or Flutter DevRel, have seen any part of this slide, so have reviewed this talk. So things I'm going to say here, they are coming directly from here into the machine here. And none of this actually reflects anything that Flutter or Dart team are planning to do in the future. Like the slides has the word necessarily, and this is actually the only slide that has been reviewed. I showed it to Michael Thompson, who is now doing a product management for the Flutter and Dart teams, and he said, you should remove the word necessarily because it definitely doesn't reflect anything that we are planning to do. So yeah, you are warned. Okay. To warm up a little bit, do you know what this is? Yeah, we're in Scandinavia. For people who are not from Scandinavia, I also prepared an additional slide. Maybe they would be able to guess it. Lego is an amazing thing. It's basically a bunch of bricks, and originally it was just 2x4 bricks, right? Here you can see a patent for the Lego brick from 1986 by Gottfried Christiansen. He's the original inventor, the son of a founder of Lego. And I was reading a book about Lego history, My Life with Lego. You should read it if you have not read it. It's a fantastic book if you're interested in Lego. And there was a very interesting story there that inspired me. Once, the Gottfried, who was the inventor of the Lego brick, he was traveling to some place, and on the plane he met a person who was running one of the big department stores in Denmark called Magazine du Nord. If you're from Denmark, you know what that is. If you are not, then you don't know. And that person complained to Gottfried that companies release toys to the market, but these toys, they never play with each other. There is no system in the toys. And the consumers would really benefit if there was a system and toys played together. And Gottfried was very inspired by this, and he then issued a memo with what's called Lego System in Play, where he outlined what he sees the perfect kind of toy should be. I think it's very interesting if you take this and apply to software engineering, because it has such things as the toy has to be compact in its dimensions without limiting the free expression of imagination. and yada, yada, yada. It has to be simple and durable, yet offer unlimited variety. And I think this is something that all software engineers can learn from. So if you look at Flutter and Dart SDK, you see it as an atomic kind of thing. It's a construction. It's like an Eiffel Tower. But in reality, it is made from many, many small pieces inside, small Lego bricks, 2x4. And if you know what the bricks inside are, you can unlock your imagination and maybe make things that nobody dreamed about. Because from the bricks that make Eiffel Tower set, I know you can build the Death Star. Well, maybe that is not the most inspiring target, but you can build, I know, Taj Mahal or other things. Not just the weapon of planet destruction, but also very beautiful things. Yeah, so sometimes it's worth looking what's inside, what kind of bricks constitute, well, Flutter and Dart SDKs, and how you can benefit from that. And that's what I'm going to talk about right now in the beginning. So why bother? Well, I was reading Twitter recently, and I read Twitter all the time, but I also have been doing it recently. And Remy, the author of Riverpot, he posted a picture where he outlined this new syntax that you could use to iterate a list and have simultaneously an element from the list and the index available to you. So the old classic index loop is dated and boring and requires a lot of typing. And with Dart 3, with pattern matching and with an extension on the lists, you can write this nice syntax down there. How many people know that this was possible? Yeah, okay, so I guess you all read Remy's Twitter. So, but then there is a question, which one is faster? So if you care about performance, how would you approach this question? Well, you can measure things, right? And specifically on native, because I'm not going to talk about JavaScript and other targets, but which one is faster on native? Well, you can go to your command line and you can type some commands, write a benchmark and compile and run it on your mobile device, on your laptop, and see what numbers are, and then say, well, this one is faster and this one is slower. Okay, this would be very easy. So we are not here today for easy things, right? We're going to do it the hard way. So we're going to first learn a little bit about how the Dart code runs when you deploy it on the Flutter, or I know if you compile the Dart code with Dart compile exe, how does it work? Well, in reality, there are these few small bricks that are involved, actually just two, here and here. You take your Dart sources and you give it to one helper program which parses that source and produces something called the kernel st. The name kernel is chosen to confuse people so that they don't figure out what I am talking about. It has nothing to do with operating system kernels. It's just a core representation of a Dart as a programming language. That's the reason for that name. And then you take that thing, which represents your program in some specific way, and give it to another program. Oh, here is a bug in the slides, but anyway, it doesn't matter. This should say gen snapshot. And you get a snapshot here, which is the binary representation of your program. So it's very simple. There are only two programs involved on this slide. And then the other part is that this AUT snapshot, it's a compiled representation of your program, which contains inside some data and some compiled machine code for the ARM 64 CPU that I shown here. You give it to the Dart runtime, and the Dart runtime can take a snapshot and create an isolate from this code. Okay, so far so good. Everything is clear, especially that machine code sequence there. It's pretty trivial. Okay, so if we were just writing the Dart code, then we would just do this. We say, okay, we import Dart isolate, and then we say isolate spawn URL, spawn URI, and we can give it a snapshot, and it will just run it. Not many people know that you can do it, but you can actually do it. And here the question is, okay, there is a chicken and egg problem. We're trying to run a Dart program, so we don't yet have any Dart running. So how do we get to this spawn URI? Well, the Flutter engine is written in C++, for example. So it goes not through Dart, but first you go there through C++. And C++ way is not that much different from Dart. You import some header file which describes Dart APIs for talking to the Dart runtime, and then you initialize this Dart runtime, and then you create a Dart isolate from the snapshot that you have. And from that point on, you are in the Dart world, and you can run the Dart code and do everything that Dart can. Okay, let's do a small practice run here. Oh, I have some Android emulator. It does not have some secret code you should not see here. So let's see if it's a good. Oops, I'm typing Cyrillic letters. Okay, so is it a good size? I can make it zoom. No, that's too much. Is it better size? Okay, is it readable? Okay, perfect. I have written a benchmark here, which has a classical loop benchmark, which just does some classical loop stuff. And then I have also written this for indexed benchmark, which does the other thing. And I'm going to compare them, right? So if I was going the easy way, I would just do Dart compile exe on the source code and run it. But I'm not going to do the easy way. So I will reset this terminal here. And then, how many people of you know Bazel? Okay, fantastic. So I wrote some Bazel rules to build parts of the Dart SDK that I would need to manually compile this to AIT without using Dart compile exe. And as I said, there are very few components that you need, very few bricks. We need the program to parse the Dart source, which is the Gen kernel thing here. We need this platform file, which contains the Dart SDK sources, like core libraries and things like that. I need Gen snapshot, with a thing that can compile from kernel AST to machine code. And then I also need a runner to actually run this AIT snapshot. Okay, and now I press this and we wait. And things don't work. Why is that? That's because don't trust the completion. To make things nicer, I have renamed some things. Yeah, so it's doing something. It's compiling things a little bit faster than Shorebird did with the iOS build, so we are good to go. Yes, so that's because there is no Firebase as a dependency, as we know. Right? Okay, so now let's do the manual things. I will zoom in a little bit more. So we say, first we want to compile the Dart source to kernel, as I said. So we take this Gen kernel thing, we give it a platform. Hopefully it works here. I remove it now. I remember that this is a mistake. Yeah. Then I say I would like it to be compiled to kernel with AOT optimizations applied, so things like tree shaking would happen and not. And then I would like it to output the produced kernel ASTs into the file called loops.dil, and I give it a file loops.dart. And hopefully when I press the button here, it does something. Yeah, it did something, did not say anything, but we have this loops.dil here. Yeps. So if we try to edit it with something, like what is those ASTs I talk about? Wow, that's fantastic, isn't it? Clearly, this was a Dart program once in its life. It's not readable. But among all the bricks that Dart SDK has inside, it has a thing called dump kernel. It takes these binaries that are produced from Dart programs, and it can dump them in a textual form that you can read. So you can actually see what came out of this first stage. Yeah, this is what came out. Now it's clearly some Dart code, right? It has like package Dart, loops.dart. The syntax is not entirely Darty, so you cannot parse it back because it represents this more condensed, more simplified form of Dart. But all the things that we put in, they're here, like the classic loop benchmark. And they're more than that. So like, for example, the compiler figured something out, like we had some variable somewhere. It contained the list originally, but we ran this AUT optimization passes on it, and it figured out that it's actually not just list, it's a specific implementation of a growable list, of a list called growable list. So this is why tree shake in tree shakes, because it goes through the program and figures out more precise information about your program than you have written in. Okay, so we have this deal file. Now we do the next thing with it. As I said, you can give it to the gen kernel thing, not gen snapshot. Yeps. And I ask it to make a snapshot in the form of assembly, and save that assembly to the file called loops.s, and as an input take the deal file, which is a kernel AST file. Okay, fantastic. It also did not crash or anything. Now let's look at this file. What is inside there? Oops. Not like this, like this. Oh, maybe not like this either. Let's do. It's a bit funny that I'm running VS Code, and then inside VS Code I run Helix in the terminal window. It's a bit baroque. Okay, so here is it's just an assembly file. So it has all the functions. Oops, don't show again. It has all the functions that the program would need to run. Like, for example, if we try to find some classic benchmark stuff, like here is a classic benchmark run. And that's the machine code for that function. We don't actually emit human-readable assembly here because we don't need it for assembling. It's just a binary representation of some ARM code. Okay. Then we need to assemble it into some binary. I can just use the GCC for that. I give it assembly file, and I ask it to produce a dylib, a dynamic library. Press enter. Okay, again, no problem. And now the moment of truth, we run this run AUT thing, which is a very simplified AUT runner, which just takes this dylib and starts running our benchmarks. Okay? Okay. So what we learned from this is that we can actually run the code quite easily. This is how the AUT compilation in Flutter works. But what we also learned is that this new syntax is freaking slow. Why is that? And when I was preparing this talk, I was hoping that they would be the same speed and I would be done with this moment. But I ran this and I was like, oh, bad situation. So being in my heart a compiler engineer, I, of course, went to try to figure out what is wrong with it. And how do you do that? Well, that's also an important skill to learn, so I'm going to show you a little bit of a glimpse of how compiler engineers who work on Dart work. So we take this slow benchmark, and then we say, well, how about we profile it? And if I was on Linux, I would just profile with perf. Because any native tool, this code that got produced there, it's native code. It's a native shared library. So any tools that work on native shared libraries would work here. So I would just take perf or simple perf on Android and profile it. This is macOS. On macOS, native tool is called Instruments, and it's only UI available, and I hate it. But it's roughly the same thing. So we're going to try to use the instrument. So I found that there is a command line interface to at least record profiles, which I'm using here. I ask it to run the program and profile it and save the profile into some file. Okay, then the file got saved. I can say profiles, launch AUT. Well, okay. Now I can open it. Boom. That's the instruments. And you see there is a it's not very visible, so I will zoom. I even had to learn accessibility key shortcuts on macOS because otherwise you wouldn't be able to see it. So it's like a normal profiling thing which you would, like in DevTools, you could do. So one thing we can see here is that this for-index loop benchmark run is for some reason calling method for doing bitwise AND operator on ints. It calls list elemented and also calls array lengths. This is a sign that something went really wrong, because if you're working with lists or arrays in Dart, you should never see these things in the profile because they should be all inlined, and you should only see your tight benchmark running there. And if you look at the classical one, its classical one is not even anywhere here that I can see because it runs. It runs without all these problems. So what is the next step? So usually if you are a user of a language and you profiled your application, you saw these things on the profile, the next step is probably go on GitHub and file a bug, where somebody who works on the Dart team would look at this bug and say, something went really wrong here. And then we would go to console again. We go to this thing called gen snapshot here. And then we would do a little bit more magical flags. So it doesn't matter where I put them. So I say here, I ask it, say print flow graph optimized, print flow graph filter. And I say I'm only interested in a classic, is it classic? Yeah, classic loop, benchmark, run, and for indexed loop, benchmark, run. Okay. And if I run it like this, it produces a bunch of output. I'm scrolling through it just to check that I can redirect it somewhere. For example, I say I want to cache on desktop for reasons that will become clear later. So, okay, run it again. Now open it. No, I'll put it on desktop. I don't want you to see my downloads. Yeah, so it's a bit dense here, but what this is, like previously I showed you some machine code, it's a bit hard to read. This is an intermediate representation used by the Dart AOT optimizing compiler. It's much more readable because it's more high level. It's not machine code. It has operations that you kind of can relate to as a human. For example, unboxed int64. Yeah, maybe not. But things like load field, I mean, you can guess what it does. It has a list and it loads something from the list. So like this load field, this is a receiver, this of a call, and then it loads this and so on. So you have a chance to read it. As I was making this presentation, I remembered something from 10 years ago, which I made and have not used since. So if I go here, I exit the full screen. So if you go to my site and you say, Hydra here, you get to a tool here which I made long ago for V8, which is a JavaScript engine, and it has all this warning that you should not use it because it's deprecated and stuff like that. But it's a tool written in Dart 10 years ago, still working, uses Polymer Dart, if anybody remembers that word. It's a framework for creating UIs in web. No, where did I put it? Oh, desktop, yes. So you saw all my documents and all my downloads, doesn't matter. Yeah, so it removes some of this clutter, so it's easier to navigate. So it's still a little bit hard to understand what's going on, but let's just look. So this is the classical benchmark. This is our loop, and it looks very simple, right? It's just loop that loops, and then boom, everything is done. If you go to the new, suddenly there is way more stuff going on. These blocks of code that the compiler has produced, it's a lot of stuff. That's bad. Then if we look at, try to find this, for example, what is going on here, you will notice things like, I'll zoom. There are things like static call indexed iterable, static call get iterator on the indexed iterable and stuff like that. So it means the compiler has failed to inline some of the code that has been invoked from the for indexed loop benchmark. And because it failed to inline, it also missed a bunch of other optimization opportunities, because if it cannot inline things, it cannot see what is happening in the target function, and as such does not know how to optimize things. So let's go to slides. Yeah. Let's skip this all, blah, blah, blah. This just repeats. Yeah, so So I looked at this and I noticed that there are these static calls for the construction of the indexed iterable, which is what happens in the source code, right? It says list.indexed, which constructs the indexed iterable. And all of this didn't get inlined. And as a result, it could not further inline this access to the element of the iterable. And that's why there are all these calls there. So how to fix it? This is actually something that if you encounter in your Dart code, you can fix it directly in Dart. You don't need to wake up any compiler engineers from their slumber. You can just go to your code where you know that compiler missed inlining opportunities and plaster this annotation on them, which tells that an AUT compiler for VM should try, or JIT compiler for the VM for that matter, should do its best to inline this method when it encounters it. So I went in the Dart SDK sources and I put this annotation on there. Then I did the Bazel thing and run it again. And it actually helped because more stuff got inlined, profile got much better. It helped by 3x. So it's a tip that you can use as a Dart developers. If you encounter a performance issue in the pure Dart code, you can profile it, see if there are small helpers that are not inlined, plaster this annotation on them. You can also try to report it back to us because then we can try to figure out if we can improve inlining heuristics to work better. Okay. Then I started looking more into that code. And another thing I noticed, again, looking at the dump from this intermediate representation, is that we are calling this bitwise end operator on an integer value, which is a very heavy operation. We're calling the whole method to get something done. But in reality, this should be just one CPU instruction that does bitwise operation. So that's a little bit harder to explain what happened, but in reality, the compiler got confused because this is a generic method on generic extension, and then it could not figure out that the element is actually an integer. So if that happens, which it should not really, you could try to fix it by putting an integer annotation where compiler got confused. You should not do it, you should report it back. So the real fix for this is to go fix the compiler. And I have done that as well as I was preparing for the talk. That improved by another 2.5x. So we are almost there in terms of speed between these two loops. And then I went further looking what are the remaining things. I found that there is this very strange code got produced. Once compiler managed to inline and specialized everything, it still was doing a little bit of very wonky stuff, like doing a comparison, then storing it at some place, and then using that to branch on comparing that Boolean value to true, and instead of just branching on the comparison, which would be a much faster operation. Again, I went and made a patch to the compiler and so on and so forth. And that improved by another 15%. So we're still in a like 50% difference or so, but what we're comparing here is the loop basically does nothing except the bitwise operation, and the loop does a little bit more operations. If I took this intermediate language and translated it back to Dart, and that's what, after all optimizations, came out of that for indexed loop. Basically, you can see it's almost what we would expect, just a little bit more. Like there is this variable that is not really used for anything useful, j, and it's always positive, but still somehow gets compared to 0 for some reason. And then there is an out-of-bounds check on accessing the list because due to this variable being present, compiler got confused and could not figure out that it can eliminate this bounds check. And these two things add that difference. But it's not as horrible anymore with all these overheads from the calls and stuff like that. Okay. I also thought about how to fix that, and that's already getting into like compiler course classes, and I have not had time to do it just for the talk. So yeah, but I'm going to do something here. So I fixed all of these things. I will make a terminal. I'm not going to try to fix them live. Also, it would involve you reading a lot of following me through the C++ code that implements Dart. So I have some difference here. Okay, I'm going to just commit it, whatever that is, it doesn't matter. Then I will do, so I have a bunch of fixes, I will just apply them on top. So I have force inlining, which does what I showed. I have improve type propagation, which I showed, and then improve fusing. Yes, okay. And now we go back to this thing. No. Oh. Oh, that's a different. I was doing too many terminals. So build. Yeah, I rebuild it. Then I recompile. We started a bit late, so I'm going to a little bit overrun. That's okay. And when I say a little bit, it's going to be a lot. So we run this, and we run this, just to show that I really fixed it, right? And did not. I mean, I could have doctored it so that just. Oh, it actually did not fix. Anyway, it does not matter. I have. That's a very bit strange. I'm not going to try to debug it. Did I forget to do something? Yeah, does not matter. Okay, it should be fixed, but it's not fixed. That means I have maybe one of the patches I did not apply. That's a bit embarrassing. Never do live demos, doctor it always. Yeah, okay. Let's skip this then. Okay. Now, for something completely different. What else could we do? Once we know how the Dart runs AOT code and stuff like that. Well, we all know Swift, or maybe not. I definitely don't, but somebody should certainly know. Here is a hello world in Swift, right? What if you could just call Dart from hello world in Swift, right? How cool would that be? Well, how do you call Dart from the code in Swift? Well, you could take the C++ APIs that I have shown you and call them from Swift, but that's not very pleasant. It's a lot of complexity to do it. So you know Dart FFI, right? Dart FFI allows you to easily call back from Dart to Swift. So if you have a function in the Swift that you want to call, well, you just declare the signature of that function that is in the kind of in terms of C, and you say, declare a signature of function in terms of Dart, and FFI handles the rest. What if we had something that works backwards? If I had an annotation in the FFI which I put just on the Dart function and said, I want this function to be exported, and then in Swift I could just call this like this. Well, let's try. What would happen if we do that? So if I go here, I have exactly that code. It highlights it as red because there is no such thing, right, in the Dart SDK. Okay. And then I have a hello world view in Swift somewhere, which wants to call Dart. Okay. Yeah, I want Dart, and then I say, hello, ask Dart. Okay, and now, what's the chance it actually works? Given the success of the previous demo, I am now not convinced. I'm going to use this. Bazel run. Okay, let's get really risky. So here, what's the chance? What's the chance? It's running, it's compiling some stuff AOT, it's compiling some Swift code, we're getting there. Oh yeah, of course I don't know the Swift. We need to say input name here, because that's what the parameter was called in the Dart code originally. Try again. Okay, well, surprisingly it actually works. How does it work if it's not, if this highlights it as red? Well, I'm building all pieces from scratch, so I could add it. I just implemented the support for that thing. I'm going to skip it because I want to free the stage for the next person, but I'm going to show you something more interesting. Yes, I'm skip. Let's imagine a little bit more. So what if we could do something completely outrageous. So Dart has many pieces, and one of the pieces that it has is hot reload. What if we could do the following? We say, we have this hello UI thing, which imports the Swift UI thing here, a Swift UI, and then makes some text here, okay? Let's try to run this. So we say hello. We kill this. And as you know, for hot reload, you need to run in the JIT. So we say Dart mode equals JIT. Okay. Yes, it's building things. It's building some DIL files because I imported a little bit more Dart code. It's running. Okay, now it's for some reason wants to accept some connections. Okay, it's good. Oh, I forgot to change the actual hook the UI. That's what happens when you run very fast, because this is still saying hello here. What if I could say dynamic view, and then I say factory hello dot make view, because that was the function name in the thing. Okay, let's try again. Because there is no hot reload for Swift code, so I had to recompile it. Okay, now it actually shows the UI that I wanted it to show, right? Okay, perfect. But if I edit things here, nothing changes, right? Okay, not so fun. Let's go to this terminal and say here, magic. And then we say, hello world. Well, what if we say hello? And then we say Swift UI, Flutter. Oh, no. Oh, now I'm nervous. N, again, N, friends. Okay. The suspense is killing everybody. It's going to work, it's going to fail like the previous demo. Wow, it reloaded. What if I say this red here? Wow, it works immediately. So how does that happen? Because it's actually Dart code being injected and rendering Swift UI there. No need for Flutter. Everything works. So yeah. Well, it's a thing that I have access to all the pieces that Dart has. The hot reload and Flutter is just an application of these pieces that Dart provides. I compile the hello world thing through something called frontend server, and then I have this driver that talks to the Dart runtime inside the phone that does all the things inside. So just 2 more minutes. Yes. And the thing is, it's not limited to Swift to iOS, of course. You can run it on your kettle if you want. And by kettle, I mean Android. So what if I kill this? I say, whoop. It's a Jetpack Compose app, which also says hello world. And then because it's a bit different, I say I want to forward one of the ports so that I can talk to it. And then I say the same magic. I'm not doing any other magic. I like my magic. Boom, it's reloaded. I can say, yeah, beat that hot reload, speed Jetpack Compose. So now it's the same code that was rendering Swift UI, just rendered as a Jetpack Compose UI with hot reload. How about that? So again, yes, there are some smoke and mirrors involved, and some of the smoke did not work, as we saw with the benchmark before. I'm really curious to figure out what went wrong. But the overall message is very simple. I'm going to skip this. The overall message is very simple. I'm a dreamer, but I want to have more dreamers in the Dart community or Flutter community. I personally dream about Dart being everywhere, where everywhere means where people who use Dart need it. And I want people to benefit from Dart being where they need it. Getting hot reload on their UIs, even though those UIs are not even Flutter, and things like that. Dart actually has all the bricks. They are well hidden inside the source code, but it's all open source. And we have a team that is happy to answer questions. If you have questions, you want to put Dart on the kettle with a hot reload of that kettle, we'll be happy to talk to you. The only thing that we're limited in is imagination, because we're a fixed size team. We're not an infinite size team. So there are way more developers outside of the Dart team than inside the Dart team or even the Flutter team, right? So the amount of imagination outside is definitely bigger than the amount of imagination that is inside. So please apply your imagination, help us bring Dart everywhere, dream big, and that's all I have to say for today. Thank you. I cannot answer questions because I am too keen on knowing why the benchmark did not improve.
Thanks a lot, Slava. That was mind-blowing. Holy shit.